Thought we'd finish off with a bit of a management perspective and just talk a little bit about what Chris and I have been working on around a new stocking framework. The original talk was a stocking decision framework, and then I changed it towards a stocking decision framework because I realized we weren't really quite there yet. But we'll just kind of wrap some of the conversations today into what we're thinking, where we're at, and then that'll be it for the day. So it's a work in progress. It's a bit of the art and the art and the science of sort of bringing to bear a decision process around stocking. So yeah, okay. So we need to facilitate lake-wide stocking decisions. I'm going to stand up here. So we need to facilitate. I'm just getting old and I can't see. Facilitate some lake-wide stocking decisions. We stock a lot of fish in Lake Ontario, and we need to find that right balance between sort of multiple fisheries outcomes for fisheries restoration and supporting recreational fisheries, and also keeping an eye on predator-prey balance. We need to consider a number of primary indicators. You've heard some of them today. I'm not going to go through the entire framework and sort of what it entails, but predator-prey is top of mind. Our ability to predict where we think the prey fish is going, looking at our Chinook growth indicators, trying to get a handle on wild production and understanding that dynamic. Also, we can have an eye on sort of managing or trying to balance out this predator-prey equation. What's new for 2023 was the development or the move to a Chinook salmon equivalence model. And I'm just going to unpack that a little bit and talk about what was on our mind when we were thinking about that. So Chinook salmon equivalence, so CSE, it's just a method to represent all fish in the same way to help manage the total prey demand. Salmon and trout species, they all have different life histories and different lifelong forage requirements. It's a similar approach that was used in Michigan, the Lake Michigan Committee. 2016, they put a framework out. We've got a couple of differences in there that we're going to point out. So just for context, in 2022, we stocked 3.9 million fish into Lake Ontario, and I'm only talking about the top predators right now, the predator fish. We're not talking about bloater, and I'm not including walleye because there's not enough walleye to be material. So really talking about the trout and salmon predators that are out there eating alewife and other species. So 6 species, 3 life stages, 4 different methods. This is pulled right out of the stocking database that you saw today, and I can't say enough about that tool. We use it regularly all the time. It's very understated on the utility of that tool. So this is just showing that this is 1 year. So Lake Ontario gets a lot of fish, and there's a whole charter boat industry, a whole stakeholder, a whole industry around that fishery in and of itself. So some background on Chinook salmon equivalence. As I said, we're concerned about predator-prey balance. We need to consider all the stocked fish. Up until this year, we went through some predator-prey concerns since 2016, and we reduced Chinook salmon stocking up to 50%. We reduced lake trout around 40%, I think. But those are really the only 2 species we really reduced. And there was a good reason for that, because they're really the ones putting the hurt on alewife for the most part. But we weren't really bringing the other species into the conversation. So now we're taking a more holistic view. We're accounting for all the fish we stock, but we need to account for those differences in survival between species at life stage and some other stocking methods. And so we also had to look at each species as a different impact on the prey fish. So just at the bottom there, just as, for example, a Chinook salmon over its lifetime average would consume 104 pounds of alewife to get to sort of, its age 3. And the average age of a rainbow trout we're using for 4 years would consume like 43.5 pounds. So very big differences in terms of what those species do over their life histories. So we looked at it, and the first thing we needed to do, and it's something Michigan didn't do, at least in the stuff I could see, was we needed to think about a standard stocked fish. You heard a little bit yesterday about yearling equivalence in the stocking database. So we're following that same approach, but because we have multiple strategies for stocking, and to avoid stocking wars with our stakeholders, where they're stocking smaller fish, so we get to stock bigger fish, and so we had to think first of all of what is a standard stock fish and come to terms with that. And once we got a standard stock fish, we had to convert those to Chinook salmon equivalent. So it's really a two-step process. So this gives you an idea of what a standard stock fish is. And it's very similar to what they're using in the stocking database. They're by and large yearlings. And so, except for Chinook salmon, we stock them out as spring fingerlings. And we're using the pen-reared Chinook salmon, which is the most commonly stocked Chinook salmon in the lake. I'll talk a little bit about that later. But we consider all of these standard stock fish to have the same survival to the fishery. Now that's going to be a leap of faith for some of the scientists in the room, and we don't have a lot of information on that, but we needed to nail down something, a rule of thumb, and so we used 10%, which sounds terrible, but it's probably higher than what's actually happening. There is literature out there that talks, if you can get 2 to 3% back out west in the west coast streams from your stocked Chinook, a manager should be happy. And that's a wild system in the ocean and whatnot. So 10% actually gives us a conservative threshold so that it's probably a high amount, but if we're concerned about predator-prey balance, we want to err on the side of high. But what that tells us is 9 out of 10 fish aren't going to make it. That's a little shocking to stakeholders. 9 out of 10 fish you stock aren't going to make it. So we had to have that conversation. So the first step was to convert all those fish to standard stock fish, and this is just the wheel of life. You've probably seen this. The stocking truck comes along and puts the fish in at various life stages. We assume equal survival to adulthood of those standard stock fish. And there are many variables in survival. The one that we're using and we find most common is the life stage, which has a more or less standard size, although there's some variation between hatcheries and between the agencies. Other factors do come into play, and it's stocking technique. Pen fish, we know, have a 2-to-1 at least survival improvement. That's from a study from Mike Connerton many years ago, but it was a really good study that evaluated pen versus direct stock fish, and we've got some really good data back on that. So we have brought into the equation occasionally some other factors that influence survival. So this is an interesting wheel here. This is, it's called the wheel of misfortune. It's also called the wheel of death. So there's 2 wheels on the internet. You can go and look up this one. And it's an education tool that is used out west in California. There's a little YouTube video on it. They spin the wheel and it lands on a number, and then you open up the number and it says your fish died because a striped bass ate it, or someone walked on the red, or a big rain event happened and all the gravel got blown out. So basically what it tells you is you start up here with eggs, and as you work around, you're losing survival. And this little red thing here is the only part that lives from wild fish. So one of the interesting, what's going on? Quick. One of the interesting things is when we stock fish, we're actually circumventing all of this natural mortality, and we're jump starting way over here, and we're jumping ahead of the curve. And that's why our stocking is different than wild. But it's a really good foil for a conversation. So if you're stocking really young fish over here, like we do with Atlantic salmon, you have a higher rate of mortality versus stocking our yearlings, or as Mike was talking about, our advanced yearlings, which had an extra 6 months in the hatchery, are even further along here and having an even higher survival rate. So it's just a way to talk to your stakeholders about the cost of stocking and also wild, and having a real conversation about how it works. And the reason fish have so many eggs is because most of them don't survive. So it's not like moose where you have one moose and it lives. It's like you have 2,500 eggs and you might get 3 or 4 adults out of it. It's the way it goes. So that's how we're treating sort of the standard stock fish. It leads us to a couple of rules where we treat fry. So we do stock fry. So we have a rule here that says if you stock fry, you have 99% mortality to a standard stock fish. And if you stock spring fingerlings, you have a 10-to-1 or 90%. So you can stock 10 fry for 1 standard stock fish. And we have some science on some fall fingerlings for lake trout and coho, where we actually had some metrics, and we boil it down to about 25%, so 4-to-1. But I'll show you an example here. It's a little different for lake trout. But here's our standard stock fish over here. So if we're talking standard stock fish, if you wanted to convert and stock smaller, earlier life stages, you could. And you could stock more of them. So there's some flexibility in the system to adjust your stocking techniques. So I'll just walk through a couple of little examples here. So what we know about lake trout for some studies is actually it's 2.4. So you can stock 2.4 fall fingerlings to one yearling lake trout. And so if you want to do some conversion there, you can work on your local stocking plan and come up with some math that lets you figure out what your stocking load is. For Chinook salmon, the 2-to-1 ratio, we called the pen fish a standard stock fish. So if you're direct stocking Chinook salmon in the river, you can actually stock them at 2-to-1 because your survival's lower. And now you've got a choice. You could put them in the pen, you could move them out, move them into the stream, increase your stocking number, but there's a higher mortality. So then, once we convert to standard stock fish, we have to convert them to yearling equivalents. So we move everything to standard stock fish, and then we start looking at yearling equivalents. And these are the numbers that were worked out through the technical committee 2021, I think, sometime around 2020, 2021. They're very similar to the numbers used in Michigan. The lake trout number is quite different, though, so it's interesting. We've got a different number than Lake Michigan for lake trout. But these are the numbers here. So basically, Atlantic salmon is 2.6 Atlantic salmon to 1 Chinook, 3.4 coho, that's brown trout, 3.4 brown trout to 1 Chinook. Chinook is 1-to-1, 3.8 coho, 1-to-1, 1.1 to 1, and 2.4 to 1. So it lets us figure out what the mix is and what the common currency is. So what it looks like for Ontario and New York, this is 2023 stocking. New York is on the left. So when we look at New York stocking of brown trout, the actual numbers in blue, the actual number of fish is in blue, the standard stock fish is in orange, and the Chinook equivalent is in gray. So because New York only stocks standard stock fish, there's no difference between it. They just calculate out. But from a Chinook salmon equivalent and prey demand over the lifetime of a brown trout, it's much less because brown trout they have a different energetic profile. When we look at Chinook, New York just stocks mostly pen-reared Chinook. So it's all even. Ontario stocks a mix of pen fish and direct stock fish. So while our actual number is higher, our effective number is lower. So that's why we have a credit, if you would, on standard Chinook salmon equivalents. When you look at something like Atlantic salmon, Ontario has a different strategy than New York, or it used to, where we stock a lot of small fry. And so we have high numbers that we put in, we convert them to standard stock fish, which is much lower because of life history, and then we convert them to Chinook salmon equivalents, and it's even lower yet. So that's why we can stock a lot of Atlantic salmon, but they don't count for a lot on the predator-prey balance sheet. Similar with rainbow trout, we stock a lot of yearling rainbow trout, so we don't have much difference in terms of standard versus actual, but when you actually calculate the Chinook salmon equivalents, it's lower. So this is how it looks. Actual fish stocked in 2023, was 4.1 million. Standard stocked fish was 3.8 and 2.5 million Chinook salmon equivalents. Once you boil it all down, pun intended, into that final calculation of Chinook salmon equivalents. And so this is just a bit of a summary, and I've got one slide that just gives you the numbers for 2024, where we're going. So the summary is we move everything to a standard stock fish. We assume a 10% return from standard stock fish. We convert all of those to Chinook salmon equivalents through the model that's in front of you here. And then we consider the Chinook salmon equivalents when determining lake-wide stocking load relative to the prey fish, and that's still in development, and predator demand. The Lake Ontario Committee agrees on what the split is, so how many fish does Ontario get, and how many does New York get? We talk about fisheries objectives of joint interest like lake trout and Chinook. We come to a mutual landscape agreement, but then there's some autonomy locally. so that I can go away and meet my local needs and Chris can meet his local needs without being unfettered by sort of, is New York okay if I put more fish in the Credit River or whatever? So this is what it looks like this year. We have a 2.8 million total lake-wide Chinook salmon stocking equivalent target. It's a modest increase from 2023, 293,000, which is roughly a 10% increase. Our allocation is about 918,000, and New York is 1.9 million. There's a whole reason for that. Ontario's happy with that. We had a conversation. That's the fish that we need to meet our objectives. We're blessed with a North Shore that puts out a lot of wild fish. We're stocking our fish into that, into the west area. And then you can see the final numbers at the bottom. Interestingly, neither New York or Ontario is spending our total Chinook salmon currency. We're leaving fish on the table. So it's not like we're maxing it out. We're sort of figuring out what we need for our objectives. So that's this will be brought up in, so we've established what we feel is sort of a way to deal with safe operating thresholds. We do need to prioritize some science needs to fill in some gaps like the index and wild production. And then Chris and I, with our help of the technical committee, need to memorialize the stocking strategy in probably a 4-page document, which will be a Lake Ontario Committee product, which would sit out there as an overarching strategy, similar to what Michigan did. So hopefully we'll have that for you next year, and we think we have it almost all done. We just wanted to kind of give you a progress report right now. Any questions?